Number 7, we are still expressing the rational expression in lowest terms, and we've been given the expression 9x squared minus 16y squared over 6x squared minus 29xy plus 28y squared. All right, so we know hopefully by now that the first thing we want to do when we're being asked to rewrite or express this rational expression in lowest terms is we're going to take the numerator and denominator and factor it as much as we can. So we're going to take what we learned last chapter and apply it to our numerator and denominator. So just factor your numerator and denominator. Well, up top, we're going to go ahead and ask ourselves those vital questions. Number 1, is there a GCF? Nope, I don't see one. So question number 2, how many terms are there? Well, we have 1 and 2. You'll recall that with 2 terms, you should be looking for either the difference of 2 squares or the sum and difference of cubes. Well, we're not dealing with cubes, right? Because we have squares here. And 9 is a perfect square, 16 is a perfect square. So we're definitely dealing with the difference of perfect squares. So how does the numerator factor? Well, we're going to factor into 3x plus 4y, 3x minus 4y, right? We take the square root of the coefficient of our x, so the square root of 9 is 3. We break our x down into x and x. We take the square root of the coefficient of our second square term, so in this case the square root of 16 is 4 and 4. We break our y down into y and y, and then with the difference of perfect squares, once you have your numbers, so to speak, your numbers and your variables, you separate those terms by a simple plus and minus, and there you have it. And then this is going to be over this trinomial that we're going to factor here in a second. So let's take a look. Question number 1, is there a GCF? Nope, I don't see one. So question number 2, how many terms are there? Well, 1, 2, 3 terms. So we're going to either factor by scissors or the AC method or trial and error. I'm going to go ahead and use the scissors method, and the scissors method says let's go ahead and list factors of 6. Factors of 6, our leading term, and factors of 28, our ending term. And let's see what we get. So the factors 1 and 6, 2 and 3, and 28. Let's see, we have 1 and 28, 2 and 14, 3 doesn't work, 4 and 7, and I think that's going to be it for 28. And we always start with the factors that are closest together, so let's go ahead and start with 2 and 3, and we'll stack 7 and 4, and if that doesn't work, we'll try 4 and 7. And now we're going to cross multiply, and you can create a little pair of scissors out of your cross multiplication, which is why this is called scissors. So let's see. 2 times 4 is 8. 3 times 7 is 21. Can we, in some combination, add a 21 and an 8 to get negative 29? Yeah, we sure can. Well, what does the sign of each of our cross products have to be? Well, negative 21 plus negative 8 gives us negative 29. And you'll recall that whatever sign we put with the cross product is going to bounce over. Whatever sign we put with the cross product is going to bounce over. And now we just go ahead and group our initial factors. So we're going to end up here with 2x minus 7. So 2x minus 7. And here we're going to have 3x minus 4. Y, right? These are y because we had a y squared at the end. So we have 2x minus 7y, and here we have 3x minus 4y. 3x minus 4y. All right, so that's how our denominator factors. So 2x minus 7y, 3x minus 4y. And now let's take a look. What factors, now that we've fully factored our numerator and denominator, can cancel? Well, 3x plus 4y, nope, can't cancel anything in the denominator. 3x minus 4y, yep, we can cancel these two things, right, because they're identical, so they go away. And 2x minus 7y, can that cancel anything? Nope. So if we go ahead and rewrite this for the final time in lowest terms, we're left with 3x plus 4y over 2x minus 7y. And there you have it. Number 7 in its lowest terms.